Chapter 4, Worksheet 5, Part A. So what you want to do here is to figure out the net force. You know that the object is sliding down with an initial velocity v initial, and you want to know if that velocity will increase or decrease. In the three cases, the initial velocity is the same. The normal force is the same, and the force of gravity is the same. The only thing that changes is the friction force. So initially, the friction force is small. What I need to calculate is the net force. So what I'm going to do, I'm going to imagine that there is an x-axis like this. And then I'm going to calculate graphically the x component of the force of gravity. So if you have a right angle over here, then this is going to be FGX. Now if I compare FGX and the friction force, I can see that FGX is larger than the magnitude of F, which means that there is more force pulling the object downhill than friction force preventing it from speeding up. This object will speed up, and the net force will be downhill. Therefore, the acceleration is downhill. In the second case, again, I carefully draw the triangle so that I can measure FGX over here. So this is my FGX. And if you do that really carefully, you will notice that in this case, FGX is the same as the magnitude of the friction force. So in this case, the net force is 0. There is no acceleration, so that velocity stays the same. In the last case, again, you want to carefully draw your FGX. So this is FGX. And what you see there is that the friction force is stronger than FGX. So the acceleration will be uphill. The acceleration is opposite to the velocity vector, so it is slowing down. Let's look at the second series now. So it's more or less the same question. The initial velocity is different, and the friction force has been replaced by a pull. So maybe someone is pulling with a cable or pushing from below. In the three cases, Fn is the same, Fg is the same. The only thing that changes is F. So we need to draw carefully the triangle that gives us FGX. In the first case, we see that the magnitude of force F is larger than FGX. So force F wins, and the net force will be uphill. Therefore, your acceleration is going to be uphill as well. Since the acceleration is in the same direction as the initial velocity, the object is speeding up. In the second case, the force is less than Fgx. So Fgx wins. Again, this is your Fgx. Because Fgx wins, the acceleration is downhill. And that object is speeding up because the acceleration vector and the velocity vector are in the same direction. Last one. So again, I tried to carefully draw my triangle. This is not the best. I'm going to try to do a better one. So this is my Fgx. And if I measure with the ruler, I can check that Fgx is the same as F. So in this case, the acceleration is 0 and the velocity stays the same.